Hello, everyone. Good morning. Welcome to our session. So for today, I am going to actually give you a demonstration on how we can say that our program is actually uh, faster compared to others. Or shall we say, I'm going to actually demonstrate to you how show you a simple program in which we are able to actually see how much is the processing time of our algorithm. Okay, so let's say for an instance, we are going to get the summation of the first n numbers. So where n is actually an input from the user. So and we take n as the input of the user, and then we are going to to get the summation of that first natural numbers. Okay, and I'm going to provide two different algorithm or two different options right here. Now in this case, I'm going to create. So I would just like to inform everyone that when we say this is not really accurate because it may vary on the processing speed, or your computer specs. Sometimes it affects the performance of our algorithm. Okay, like for an instance, you run a certain application that requires much memory, so most probably the our program will also be affected. Okay, so this time I'm gonna create a program which yes, as I've said, sum of natural number. So there are two possible solutions for this. Number one, let's say we take input from the user, let's say J option pane, sorry, in N, let's have J option pane that show input, okay, and then let's have here, what is this? Enter N value, okay. So probably we can ask the user to like enter positive value. So integer that parse int this. Yeah, so we can enter this one. Sorry. Okay. First solution. This is the first solution. So let's say we have here for uh, int I is 0, then I is less than the value less than or equal to n, and uh, x plus plus. So let's start with 1 na lang. Waste of time. Anyway, right here, so why x? Have to use I. So right here, we'll have another third party or temporary third temporary variable. Let's say we'll be using variable sum. Sorry for that. The keyboard, not mine actually. So we have here sum plus equals to the value of I. Okay, and then uh, we are going to display right here. So and the sum of uh, first. You don't have to be this uh, formal, but let's say the sum of the first uh, n natural numbers have sum. Okay, so this time let's uh, run the pro. Yeah. So let's. I know we already know that this will get the sum, but this time we are going to calculate first the have long say num. No, so start is equal to system that we'll use nano time, but this one is medyo we are not able to capture the time. We have nano time. Okay, and then we'll have another here, another time, which is end. Can actually like elapse. Is elapse the right one? But for the difference, something like that. So we have and minus start. And then we can display parang like num of units, time units, time units. We have here tabs. So let's can actually put this one into the right, and then let's have here sum of the first natural number, and then sum, and then the time units is going to be displayed in this case. So let's run the program now and enter, let's say 50. So we have time units is this one. It's a little dako, no? So we have the efficiency of our ano is not that we have not that fast. Let's say 5 happen. It's always start and then end. And then we have here elapse. Yeah, it seems that it's that is always the case. Let's try to use millitime. Current millis. And we have here like 10. So it's 3236. Okay. And then we'll have another one. That's 100. 4235. Okay. So let's have another solution. So in this case, we are going to create another solution for this one. Let's say we have sum of n number. Basta, like that. Okay. So right here, we are going to follow or get the value from here. Then instead of using loop or using loop, we are going to also copy this one, then paste it right here. Now, instead of loop, we are going to use the mathematical formula for getting the value of sum of n. So actually, we just remove loop right here, right? So here we are going to use the formula, which is n times n plus 1, 1 divided by 2. Okay, so let's see. Let's have 5 here. So the value, the first, the sum of first 5 natural numbers is 15. Let's have here 5. What happened? Enter a value. Let's say n 5. We don't have J option pane. My goodness. So we are going to copy paste J option pane, and so it's 2867. So right here, let's say we have 5. It's yeah. So what happened? still the same. Probably we'll just close things right here. I mean, we just close other application. Let's have here 5 313 115. Let's say we have here another one 5. So at least 2732. But because of we, it's only going to be processing as like few numbers, no? So meaning to say this would only like loop 5 times. Okay, let's have larger numbers because that's the case in time efficiency. I mean to really see the the time efficiency or the efficiency of our program. Let's say we have 1000. Okay, I'm going to copy paste this one. Their value that is 16,263 millitimes or milliseconds. Now we have 16, that's 16,000. How about here? We have that's 4,000. So it's actually more than a half, right? So this we could now tell you that, I mean, I could now prove to you that this solution is actually a lot better, a lot efficient compared to natural numbers. So how much more if this one becomes, if we are actually going to like calculate the 10,000, I mean, enter 10,000, this like 9,000. So right here, uh, 10, so it's 3,000. So it's more than half, no more than half. It's this one is again become as it's more efficient compared to the other solution. Okay, so that's it. That's the basic of how you are actually able to calculate the efficiency of your algorithm. So again, all boils down to this that this there's no exact or accurate really now to prove to you that uh, this one is better than this one uh, only after a thorough parang analysis. So that's the time you do a certain analysis of algorithm, like you use the certain notations. But this is just one thing that I can prove to you that one particular solution is actually different in terms of the processing speed to the other solution, especially if it if especially if you are going to feed uh, like large numbers in it. So I believe you are able to see it naman. But again, also it is going to vary. It may vary. It depends depending on your computer specs as well as the the applications that you are actually currently running. Okay, because it affects the uh, time efficiency of our program. All right, so I guess that would be all, and thank you guys for listening. Bye bye.